Hello everyone, welcome to Royal Palace online classes. Last class we discussed about Newton's laws of motion. Today let us discuss about frictional force. Frictional force. Friction is a opposing force when one body is resting on another body. If a body of mass m is present on ground, assume, or it is present on a body like table, you assume, it is present on a table. Now when two bodies are in contact, if there is a relative motion, that means if one body is sliding on another body, then there will be an opposing force. The force which opposes the relative motion between the two bodies which are in contact with each other is called frictional force. Now you see, this body of mass m is resting. I applied some force. Assume that I applied 5 Newton. The body is not moving. Still it is at rest only. Why? Because it is in contact, it is locked with the body which is present down. So because of that it is not moving. If I increase the force, then body starts, suppose if I increased it to 6 Newton or 7 Newton, then body starts sliding. So this is called as frictional force. So when one body is sliding on another body, the force which is going to oppose that relative motion is called friction. Then what is the cause for friction? What is the cause for friction is, there are two types of surfaces. One is rough surface, other one is smooth surface. Rough surface is which is having irregularities. If you see these rough surfaces, they appear like smooth only. But if you see microscopically, suppose if you see the microscopic view of the table, this will be the design, and microscopic view of that block, will be like this. Now if you observe this, what happens here, you can observe that there will be some ridges and grooves. There will be some ridges and grooves within the surfaces. So because of that ridges and grooves, what happens? They interlock with each other. Interlocking will take place. Due to that interlocking, it is locked here. So due to that, there exists friction. So friction is the force which does not allow the bodies to detach from each other when they are in contact. So that is because of some ridges and grooves which we can observe in microscopic view is an example. Next, types of friction. First type is static friction. Second is kinetic friction. Next is rolling friction. So first let us discuss static friction. Static friction is friction at rest. It is friction at rest. Static friction is friction at rest. That means initially the body is at rest. Okay. They are interlocked here. They interlocked here. So if you apply force, they should detach. So the force required to detach them initially is called static friction. And it is observed that static friction is greater than kinetic friction. And suppose if a body of mass m is there, I applied some force F, still that body is at rest only. If I go on increasing the force value, at a certain value of force, body will detach. That is called limiting friction, maximum static friction. That is maximum value, maximum static friction. Maximum static friction is called limiting friction. Is called limiting friction. Maximum static friction is called limiting friction. Maximum static friction is called limiting friction. And after making this body to in motion, then when it is moving, the friction which is present is kinetic friction. Kinetic friction. And this kinetic friction is less than static friction because that is common experience. When body is in movement, interlocking is not possible. It will be little bit less because already it is in motion. So they will not contact more. That ridges and grooves, they will not contact more. That's why kinetic friction will be less than static friction. And next, rolling friction. When one body is rolling, on another body, rolling friction comes into play. Next type of friction is, next topic in this is, we will see the formula for friction. On what factors friction depends? On what factors friction depends? The factors on which friction depends is normal reaction. Frictional force is directly proportional to normal reaction. So when a body is resting on another body, the force which is acting perpendicular to the lower surface of upper body is called normal reaction. And frictional force is proportional to normal reaction. And frictional force is equal to mu into n, where mu is called coefficient of friction. Mu is called coefficient of friction. And this coefficient will be, experimentally we have seen that it will be less than 1. It is less than 1. That is mu value. Now this normal reaction is different in different cases. So for that we will see that normal reaction, different cases. Before going to that, the angle made by the frictional force and normal reaction with the normal reaction is called angle of friction. Is called angle of friction. If you take frictional force is opposite to your motion, opposite to the motion. So this is normal reaction, this is frictional force, this will be the resultant. So this is the angle made by the resultant of normal reaction and frictional force with the normal reaction is called angle of friction. Now let us see the different types of normal reactions, what you will get. So that will first motion of the body on an inclined plane. Will take motion of the body on an inclined plane, rough inclined plane will take. There is a inclined plane of inclination. There is an inclined plane of inclination theta. Okay. A body is sliding down the inclined plane. Body of mass m is sliding down the inclined plane. So here mg will act in this direction, and if this angle is theta, so this angle also, if this angle is theta, this is 90, this will be 90 minus theta, this will be again theta. So in this direction, if you resolve, this will become mg cos theta. You resolve this in this direction, it will become mg sin theta. Now this is the normal reaction. The force which is acting perpendicular to the lower surface of upper body, this is the normal reaction. So in this case, normal reaction is equal to mg cos theta, and this is, from this you can write frictional force is equal to mu mg cos theta. And if you separate this body from the system, isolate it, and if you draw all the forces acting on it, this is normal reaction, this is mg cos theta. Okay. And here down the inclined plane it is acting mg sin theta. Okay. Okay, this is the condition. Now if you observe, assume that body moving down, means body is moving in this direction, acceleration is in this direction. When acceleration is in this direction, according to Newton, m into a is the net force, that must be equal to, when body is moving in this direction, so frictional force act in this direction. So mg sin theta should be greater, mg sin theta minus frictional force, that is mu mg cos theta. So m you can take common and we can cancel. Then acceleration a is equal to g into sin theta minus mu cos theta. This is the acceleration of the body. If you want to calculate time taken to reach the bottom, time taken is equal to time taken. How you can calculate? Initial velocity is 0, v is equal to u plus ad. In that you can calculate time, or by using the distance, s is equal to ut plus half at square. Here initial velocity is 0, length of the inclined plane you take L, so L is equal to 0 plus half, in place of acceleration you have to write g into sin theta minus mu cos theta, g into sin theta minus mu cos theta. Therefore this you will get t square. So t square is equal to 2L by g into sin theta minus mu cos theta, sin theta minus mu cos theta. From this you can write t is equal to under root of 2L by g into sin theta minus mu cos theta. Sin theta minus mu cos theta. Okay. Next, if you want to calculate velocity on reaching ground, reaching bottom, v square minus u square is equal to 2as, that is v square minus 0 is equal to 2 into g into sin theta minus mu cos theta into L, and v is equal to under root of 2g into sin theta minus mu cos theta into L. Okay. This is the when body is moving down. Suppose if body moves upwards, is moving upwards, in this case frictional force act down, mg sin theta is also acting down. So net acceleration m into a is equal to mg sin theta plus frictional force, that is mu mg cos theta. M and m will get cancelled, then a is equal to g into sin theta plus mu cos theta. Okay. Then in place of acceleration you can substitute this formula. Suppose if the plane is smooth, if plane is smooth, you can take mu is equal to 0, then acceleration becomes acceleration a is equal to g sin theta. Acceleration a is equal to g sin theta. Next, we take one more example. That is when a body of mass m is pressed towards the wall with a force F. Then in this case mg acts down, normal reaction will be in this direction because these two are in contact. So in this case normal reaction is balanced by applied force. So mu into F, if the body is at rest, should be equal to m into g, then F is equal to mg by mu. This is the force. Okay. So these are the some of the applications regarding friction. Still many applications are there. We will see in the next video. Thank you everyone for joining me.